the acid. In this video, I want us to look at some questions that you are likely to see in your end of semester or your end of term examination. Okay, these are questions on strong acids and bases, very technical questions. Now, this question here says that you have 100 cm cube of 0.1 molar sodium hydroxide, which was made to react with 200 cm cube of 0.05 molar H2SO4 solution. Now, calculate the pH of the resultant solution. So, well, this is a strong base and this is a strong acid. So, what is going to happen? Is it going to be a completely neutral solution or is it going to be acidic or basic? That is what you are trying to find by knowing the pH of the solution. So, the first thing we have to do is to analyze the solution. And to analyze that, I love to do this. Let's say this is let's take this as a beaker, and let's say this is 100 cm cube, right? And this 100 cm cube is the volume of sodium hydroxide solution. And I have another beaker, which is 200 cm cube, okay? And this beaker contains sulfuric acid. Okay, let me use a different color for that. This one contains sulfuric acid. Now, they are telling us that these two solutions was made to react. That means they've been combined. So what happens? Remember, this is sodium hydroxide and this is sulfuric acid, H2SO4. Okay, so they combine these two solutions and the resulting solution is going to be what? It's going to be a mixture of the two. So if this is a resulting solution, so this is going to be 300 cm cube, right? And in this solution, we are going to have products. So this is a combination of the two solutions. All right. Now, what do we have to do? Now we would have to find the mole of the two. Okay. So let me pick the white one here. Right. So first, we need to know that we need to find the mole of the base, and the acid has a volume of 100 cm cube and a molarity of 0.1 molar. 0.1 molar. That means that the mole, which is equal to concentration times volume, is going to be what? 0.1 times the volume, which is 100 cm cube, but when we convert it to dm cube, it's going to be what? 0.1 dm cube. And so the mole of NaOH is going to be equal to 0.01 mole, right? Now, what about the acid? The acid has a concentration of 0.05 molar, right? 0.05 molar. And then it has a volume of 200 cm cube. Then the volume is going to be 0.2 dm cube. So mole is going to be 0.05 times 0.2. So the mole of the acid H2SO4 is going to be equal to 0.01 as well. 0.01 mole. So now we've combined these two solutions. So what is the equation that's relating the combination in this beaker? The combination in this beaker. So when we take what is happening there, we have H2SO4 combining with 2 moles of sodium hydroxide, okay, and it's going to give us the salt sodium sulfate plus water. And in this case, it's going to be 2 moles of water. We have to make sure that everything is balanced, okay. All right. So what are we to expect? Now we know that the mole of sodium hydroxide that reacts is 0.01. So initially we had 0.01 mole of sodium hydroxide, and we also have 0.01 mole of H2SO4. Now remember, this is the initial moles of the reactant species. At the time, we are not going to have any of the products in the solution. Okay, so we say this is initial. Now at equilibrium, what is going to happen in the equilibrium is that the mole ratio between sodium hydroxide and H2SO4 is 2 is to 1. What it means is that when we have a full mole of 0.01 of sodium hydroxide reactant, we are going to have half that mole of sodium hydroxide, half that mole of H2SO4 to give us the product. So at the initial, at the equilibrium, we are going to have all of the sodium hydroxide reactant to leave us with 0.00 mole, and then we are going to form we are going to form 0. Remember, what is going to left here is going to be half of this, and so we'll have 0.005 mole of H2SO4 left. That means this is going to be the mole of the product that is going to be formed. So we'll have the same mole of the salt for the salt, 0.005, and the mole ratio between H2SO4 and water is 2 is to 1. So it's going to be twice for H2O, so 0.005. Good. All right, then. Now, this is what we are having for the product. You realize that we do not have any excess sodium hydroxide left in the solution, but we have excess H2SO4 left in the solution. So what is in excess is H2SO4, and sodium hydroxide that has been consumed completely, we call it limiting reagent. Limiting reagent, okay? Now, so we'll say that 0.005 of H2SO4 reacts with 0.01 mole of sodium hydroxide, okay? Because the mole ratio is 1 is to 2. So now let's find out what is going to happen in the solution. We have we have a total volume. We have a total volume which is going to be the 100 cm cube of sodium hydroxide and 200 cm cube of H2SO4. So we have 100 cm cube plus 200 cm cube, which is going to give us 300 cm cube. Okay, and so we'll have 0.3 gm cube, right? So we are trying to find the mole of, we are trying to find the concentration of H2SO4 that is left in the solution, and we'll see what we'll do with it very soon. Okay, so excess mole of H2SO4, excess mole of H2SO4 is equal to 0.005, and then total volume is equal to 0.3 gm cube. So what is the concentration of H2SO4 left in the solution? So concentration of H2SO4 left is going to be mole over volume. And so we have 0.05 mole divided by 0.3 gm cube. And what is this going to give us? This is giving us 0.0167 0.0167 molar or mole per dm cube. Okay, so this is the concentration of H2SO4 we have left. Now, from here, we know that, or we have an idea that the resulting solution is going to be acidic since we do not have any basic species or sodium hydroxide left in the solution. Okay, so we'll go ahead and dissociate the H2SO4 to find the concentration of H plus because we know that pH is equal to the negative log of H plus concentration, right? So let's do that. We have H2SO4, which is a strong acid. Remember, it's aqueous. So it's going to dissociate to give us 2H plus, also aqueous, plus SO4 2 minus aqueous, right? Now, this is strong acid, which means it dissociates completely. So if the concentration we have initially was 0.016 molar, 167 molar, at the time, we're not going to have any of this in the solution. So this is our initial stage. Now at equilibrium state, we're going to have none of this H2SO4 in solution because it's a strong electrolyte, which means it dissociates completely. So we have 0.00 left, and then we are going to have the mole ratio is 1:2, so it's going to have twice of that, which is 0.0167. Okay, and then we're going to have 0.0167 for sulfate anion. Okay, now from here we can tell that the concentration of H plus is going to be 2 times 0.0167, 2 times 0.0167. Okay, and that is going to be equal to what? 0.033 molar or mole per dm cube, right? Good. So what can we do now? We know that pH is equal to negative log of H plus concentration. And so this is going to be negative log of 0.033. Okay. And we will be having 1.48. Good. So if you do this, then that's the right way to go about a question like this. The solution is going to be acidic, even though it's a combination of a strong base and a strong acid. We're going to have excess of H2SO4 in the solution, and so the solution will be acidic, okay, because the pH is 1.48. That's a very strong acid. All right, let's go ahead and look at this. Now, you can pause the video and try this question. All right, this question says 10 cm cube of H of 0.1 molar HCl was made to react with 10 cm cube of 0.1 molar magnesium hydroxide solution. Calculate the pH of the resulting solution. Well, this is just similar to what we just did. Okay, so it's the same thing. What we are going to do is to try to find the mole of the species that we are combining. We are going to try to find the mole of the species that we are combining. We have HCl and we have magnesium hydroxide. Again, both are strong acids and bases. Okay, all right. So, what is going to be the mole of HCl? The mole is going to be the volume of HCl, which is 10 cm cube. 10 cm cube to dm cube is 0.01, okay, times the concentration, which is 0.1 molar. So the mole is going to be what? Point that. So the mole is going to be 0.001, okay, 0.001 mole. Okay, that's the mole of HCl. Now let's try to find the mole of magnesium hydroxide too. Now, the volume of magnesium hydroxide is also 10, which means it's going to be 0.01 times the concentration, which is zero point 0.1. Okay, so we are going to have 0.001 moles. So we have equal moles of HCl and magnesium hydroxide. So the next thing to do is to try to find out what is going to react. So this is the point where we have to write a reaction equation. So we have magnesium hydroxide plus 2 moles of HCl. We are balancing the equation, which will give us magnesium chloride plus 2 moles of water. Okay, this is a balanced equation. All right, initially we have 0.001 mole of magnesium hydroxide, and we also have 0.001 mole of HCl, while we have none of this in the solution. Then at equilibrium, we are going to have all of the HCl consumed, and so it will be left with 0.00. All of it is consumed. And what is going to be left for magnesium hydroxide? We know that the ratio is what 1 is to 2, that is half. So if we have all of HCl consumed, then at the time we would have had half of the mole of magnesium hydroxide consumed. And so the mole of magnesium hydroxide is going to be 0.005 left in the solution. Okay, and so that's the mole of the products that we are going to have as well, because it is half that is consumed, and the mole ratio is 1 for magnesium chloride to 1 magnesium hydroxide. So we have 0.0005, and then this is going to be twice 0.0005. Okay, but then we are not really interested in the product. We are trying to find out which of these two species remain in the solution, and the one that remain in the solution will determine the pH of the resulting solution. So we have excess magnesium hydroxide in the solution. Okay, so excess mole of magnesium hydroxide is equal to 0.0005 mole, and then in this case HCl is our limiting reagent. Now we have to find the total volume. Total volume is going to be the two volumes 10 cm cube of HCl plus 10 cm cube of magnesium hydroxide. So 10 plus 10, which is 20 cm cube, and this is equivalent to 0.02 dm cube. All right, now let's find the concentration of magnesium hydroxide in the solution. In the resulting solution. So this is going to be the mole over the volume. Now the mole that is left is 0.0005 divided by the volume, which is 0.02. So this is mole over dm cube. Okay. Now what will this give us? This is giving us 0.025. 0.025. Okay, all right, mole per dm cube. That's our concentration. Now the next thing to do is to dissociate the base, which is magnesium hydroxide, dissociating to give us magnesium 2 plus 2 moles of OH minus. Okay, initially we had 0.025 of magnesium hydroxide, while we have none of these guys in the solution. Then at equilibrium, because it's a strong base, it will dissociate completely, and then we're going to have 0.025 of magnesium plus in the solution, and twice that concentration for hydroxide anion, which is 0.025, 2 times 0.025. So from here, we can say that the concentration of OH minus is 2 times 0.025, which is going to be equal to, what is going to be equal to 0.05 mole per dm cube. All right, now POH we know is equal to negative log of OH minus concentration, right? And so we can say that negative log of 0.05 will give us, negative log of 0.05 will give us 1.30. Okay, but then this is not what we are interested in. We are interested in pH. So pH is equal to 14 minus POH. So 14, this implies that we'll have pH to be equal to 14 minus 1.30, which is going to be equal to 12.70. So this is how to go about questions like this. So you first find the mole of the two species, find the excess mole, and then you tally the volume to get a total volume. You find the concentration of whatever is left, dissociate it, whether it's an acid or base that is in excess, and then you find the concentration of the resulting species, either hydroxide anion or H plus, and then from there you can find your pH. Or if it is a base, you find a pOH and subtract it from 14 to get your answer. I hope this video helps you in your class test or your exam. Thank you. Remember to like and subscribe.